Hello, everybody. How are you doing today? Good? Good, good. I'm just going to ask a couple of questions to help our folks in the back, with the sound and all. How many people here are application people? Okay. How many are networking people? Okay. And DevOps? I'm sorry, DevOps, if I didn't include you in both. Okay, good, good, good. And normally I usually do a joke. So for the networking people, I forgot. So do you have any good ARP jokes? I didn't get it, did I? I hear the groans. Okay, okay. My name is James Wenzel, and I'm here to talk about how to choose the right load balancer for your workloads. This is a level 200 talk, so won't be really looking into any protocol headers or anything like that. I apologize. It's basically geared for folks who know AWS, know the console, and have familiarization working around in and of it, but not really going super, super deep. That being said, I'm not going to disappear after this meeting or after this breakout session. I will be in the hallway on the side if you want to talk. I'll have a couple of friends with me that are also on my team that can also help out answering some of the questions. See how I just roped you guys in there? So hopefully we'll have a good time. Okay, so my name is James Wenzel. I've been with AWS for about 5 years now. This has been my 5th reInvent. And I'm really glad that you guys are here. It means a lot to us that you're here to show support and to participate in these events. So I just want to make sure that I let you all know that. So today's agenda, we're going to take a look at the available load balancing technologies that we have. Notice I said technologies. Some of them are considered load balancers. One's considered an accelerator. We're going to break down what makes them unique. So I won't be doing a feature-by-feature comparison of every load balancer. That would be very boring, and I'd see a lot of you get up and probably leave. So we're just going to kind of highlight the top characteristics of what makes that load balancer special. And then I try to tie everything together. So as I move along in my presentations, I usually try to add them to like an existing workload or a fictitious workload to help us kind of understand what this looks like. So what load balancing choices do we have? So the first load balancing choice is the ALB, or Application Load Balancer. This one operates at layer 7. Its targets are IP instances, Lambda, and of course containers. And the protocols are your layer 7, HTTP, HTTPS, and now gRPC. The next load balancer that we have is the networking load balancer. Networking load balancer is pretty fast. It operates at layer 4. IP instances, it can actually talk to containers. We've recently added ALB as a target, which is pretty cool. And it talks TCP, UDP, and TLS. The next load balancer in the ELB family is the Gateway Load Balancer. It's one of my favorites. The Gateway Load Balancer is a pass-through load balancer that operates as a layer 3 gateway, and it also operates at a layer 4 load balancer. It targets IP addresses, and it targets instances, and it understands IP. We have the Classic Load Balancer. The Classic Load Balancer is the one that if you've been doing AWS for quite a while, it was probably the first load balancer that you've used. It operates at 4 and 7. It targets EC2 instances and EC2 Classic instances, and the protocols, TCP, SSL, TLS, HTTP, and HTTPS. One of the questions that I usually get asked is it going away? Right? We have no plans of making it go away, but the active development that we are doing on our load balancers and bringing in new features happens to be on the application networking and gateway load balancers. And then there's that one extra load balancer I told you about, or acts like a load balancer, is Global Accelerator. Global Accelerator, I know that TCP UDP isn't a protocol or a layer, it's a layer 4, right? But that's really where it plays well. It targets IP, ALB, and NLB. So it uses IP addresses as well as the existing ELBs for its endpoints. And then, of course, it operates at TCP and UDP. So if I'm breaking these down to 2 different types, I've got the elastic load balancing. I've got the global accelerator. Now, for the sake of this talk, I'm not going to talk about the classic load balancer. Because again, most of our advancements and features are actually happening on the ALB, NLB, and gateway load balancer. So those are regional constructs, which means they operate within a region. They sit on multiple availability zones. Hopefully you choose multiple availability zones for all of your workloads because, well architected, we don't want stuff to go down and have your customers suffer. And they are pretty much compute-based, such as the ALB, Application Load Balancer, and they're hyperplane-based, which means at-wire speeds, which is the gateway load balancer and the networking load balancer. The benefits of the hyperplane, of course, is you get to go super fast. It's pretty much at code. You only have to worry about things like flows as opposed to handshakes, and that's why it gets its speed. The compute-based basically means that we have a VPC that is spun up just for you, managed by us, where we have the scale going in and out of compute-based resources to power your application load balancer. So the difference between ELBs and the global accelerator is the global accelerator is, as it is mentioned, global. It's not region bound, it's global bound. So what that means is through the use of POPs or points of presence that are actually around the globe, it can actually help you load balance between regions. Using, of course, as what you saw on the previous slide, the ELB, ALB, and IP addresses for its endpoints and its targets. And there's more finite controls that you can do with that when you kind of group these all together. So we're going to take a closer look at each of the load balancers that we have in play. And I'm going to put something up on the screen. You will not see a load balancer listed right away because I am quizzing you on what I just showed you to see if you're all paying attention. So we have a load balancer that has instances as a target. You can have Lambda, containers, IP address. You have redirects, desync mitigation. What load balancer is this? Application load balancer. Good. So these are the unique features for application load balancer. It is one of the better load balancers that we like to recommend putting in front of containers, right? Because of the fact, especially for Kubernetes, you can eat a lot of IP addresses. We have the ingress controller for the containers, which allows you to add and remove containers and have your load balancer actually understand those changes without having to make manual changes in itself. This can be gotten on GitHub, downloaded, and used. It's actually quite cool. The other thing, too, is desync mitigation. That basically means that what you can do with this load balancer is all the requests and subsequent requests that go to your actual backend instances, you can set how strict or how easygoing you want to be for the traffic to be inspected if there's any variances. Because sometimes there is variances when you have consecutive communications to your backend instances. The other thing, too, that I want to point out, which is pretty cool about the ALB, is it can actually offload authentication. So using Cognito and hooking into something like SAML, you can actually go ahead and have your applications not worry about the authentication piece and offload that to your load balancer. Now, of course, one thing I want to make sure I mention for the ALB and then the next load balancers that we're going to be talking about, the NLB, they do TLS termination. So you can also offload that. I've actually done TLS termination before on an EC2 instance and found out that my bill was quite high because of all the connections coming in when I was a customer. So it's a good thing to actually use. So let's take a look at what kind of workloads are good for the ALB. Now, of course, we mentioned it is a layer 7, HTTP, HTTPS, but the different areas that are good for it is things like the advertising space, right? Within advertising, you can do A/B testing. You can basically look at any outstanding requests. You have improved performance coming in for things called connection pooling. So if you're actually collecting information on ads or adware, and you have multiple clicks coming in the same scenario, with connection pooling, you can actually make it a little bit quicker because you can use the same connections. The other thing you can use it for is media and entertainment. So when you go to the front-end page, you go ahead and authenticate yourself to that front-end page to select whatever media you want, be it music, video, anything like that. So it could basically sit in as the front-end portal. So if we're going to take a look at this in action, we've got our packets coming in, goes to our ALB shuffles it out to the multiple targets. The ALB, in the front end of it, will have an endpoint, and that endpoint will have the IP addresses that reflect how, its growth or its expansion within that sidecar VPC I talked to you about, which will consume IP addresses in your VPC. So you need to be aware of that. So as you can see here, I've got it going to EC2 instances and Lambda. You can also have it go to Lambda and to containers if you're looking at more of a serverless infrastructure. I'm not saying that you want to replace all of your API gateways with ALB, but you need to really look at if you're going to be creating a serverless application, do you need everything that the API gateway has? If you don't, the ALB is actually a little bit quicker. And don't tell the API or serverless team, but it's also a little cheaper. So this is a good thing for you to choose. And then, of course, the wide range of targets that you can use for the ALB is pretty awesome. So we've recently released some things for ALB. I've mentioned the desync mitigation and gRPC. One of the other things to mention that we'll be getting into a little bit later on in the presentation is the fact that the ALB can now become a target of NLB itself. We'll go over the cool things that NLB can do, and then we'll talk about why that's pretty awesome, but I also have it kind of spoiler listed here, the static IP address and private link. We'll go through those in a little bit. The other thing to note is that we have the ALB on the edge with Outposts. So if any of you are using Outposts or thinking of using Outposts, which is kind of like the AWS rack sitting in your data center, ALB actually operates on that. The other thing, too, I want to mention with ALB, which is kind of important, is that it has integrated WAF, or Web Application Firewall. And one of the cool things that we did is we made it so that if the WAF fails, it will fail open. So that if there is a problem with a rule or there's an issue, it doesn't take your application away from your customers, which would be kind of crappy, for lack of a technical term. So let's add ALB to a workload. So I've got a workload here. I've got a front end, I've got an API layer, and I've got a database layer. And I love ALBs, and I'm going to put them everywhere. And one of the reasons for this talk is because you could use one load balancer if you really, really tried hard to do everything. But what we want you to do is maximize the differences of the different load balancers and help you get the best out of your workload. So now we're going to move on to the next load balancer. We have instances. ALB is a target, containers, and IP. Low latency, it's super fast. Zonal isolation, which basically means you can bring it down to a single zone or an AZ for even faster speeds if that's what you need. Operates at layer 4, private link, and it is a NLB, yes, network load balancer. Again, this operates on the hyperplane, right? So it's going to have that software as a service, software networking speeds, right? Wire speeds, if you will, if you're an old person like me. It only really worries about flows, right? As I mentioned before. The long-lived connections, awesome for things like, well, let's take a look. Gaming. How many of you have ever gamed and had like a low response time and you were just beating the living crap out of everybody else and they all hated you? Well, if they all had network load balancers as the gaming companies, that wouldn't be an issue, right? Because of the fact that with gaming, the thing you need is long-lived connections, as well as you need to have that fast speed, low latency, all of that fun stuff. The other thing we can do with this is data ingestion. So if you have instances that are running a database, right, and you want to, you're not using RDS, for whatever reason, the database that you chose isn't an RDS database, you can put a network load balancer in front of it and allow them to scale. Please make sure that your databases actually understand that there's another database and they have to keep in sync, because that would be weird. But they would allow them to scale in and out, and you would have a single IP address, right? Because the network load balancer, one of the benefits is the front end is not an endpoint. It has one IP address, and that one IP address is static. It will not change until you destroy that NLB and create a new one. This helps out for things like allow listing or other things such as IoT. I worked for a company a while back, and they used to create these healthcare devices. And I remember every time we wanted to put everything, because I was in the networking team, everything we wanted to put on there, they would always tell us, you can only have 3 things: IP address, default router, and subnet mask, right? Well, every time we had to change an IP address on the back end, we had to go and update tons of IoT devices. That still exists today. So if you have something like a static or a non-changing IP address, it's great. The other thing that it's great for is if you have tons of things coming in and speaking to your NLB. right? Because of the fact that you might have a lot of sensors out in the field for whatever you do with IoT, having something that can handle all those connections pretty much all at once, it's great. And then again, long-lived connections will allow you to actually download all of the data and not get cut off in the middle. And then we can go back to our friends in media and entertainment. So we had the ALB that was for the front end or the portal, and now we have the NLB, because again, long-lived connections, the last thing you want to do is start listening to a song and after like 20 seconds it ends, right? Or you only get to see parts of a TV show and have to refresh over and over again. NLB will help you with that, right? Again, high number of concurrent connections, long-lived connections, and high throughputs. So let's take a look at the NLB. Here I have the EIPs outside of the VPC. So the way that I make my NLB a public NLB is I'll bind an elastic IP address, which does not change unless you want it to the non-changing static IP address of the NLB. We've got our fast connections going through. Everything is fine. But NLB has some special tricks. So we have private link. How many of you know what private link is? Okay, we got a fair number. But for those of you who don't, because not everybody raised their hand, and because they have the microphone and you have to listen to what I say, I'm going to tell you. Private link is a methodology that allows you to communicate over the AWS backbone without having to go over the internet, without having to do any type of VPC peering. It is a secure unidirectional form of communication. So on our right-hand side and left-hand side VPCs, you can also see another benefit for private link, and that is the fact that the CIDR blocks are the same. So if you have acquisitions, overlapping CIDRs, things like that that are of a concern, and you can withstand unidirectional flow, private link helps there. Another thing, too, that it helps out with is that you can use it for secure communications to other customers. So this right here could be, let's say, on the left-hand side, your account that you're going to provide something to other AWS customers, and all they would need to do is they would create a private link and connect it to your network load balancer. Now, private link does work with other AWS services, but behind the scenes is kind of similar to what you see here. In this instance, you are controlling the network load balancer, and you're going to offer that service. So what about hybrid? Everyone's been hearing about hybrid technologies, going from on-prem to your AWS workload. Well, with private link and NLB, you can definitely do that. You can also go with a static IP address with NLB, but with private link, the one thing that's pretty cool, with the ENIs, they actually get an IP address from the local subnet. So because they get the IP address from the local subnet, that IP address is actually routable as it's on the ENI, or Elastic Network Interface, and it can be reachable over things like VPN or Direct Connect. Now I've got, of course, DNS here too. Private link supports vanity DNS. There's a lot of other goodies that private link does, but this isn't a private link talk. This is a ELB talk. So we'll get back to the ELB. The other thing that I mentioned was the ALB as a target. So this works to help both the NLB as well as the ALB. The way that it helps the ALB is a lot of times you hear, I need a static IP address for my ALB. I want to be able to allow list, or I have a lot of those other things that we've talked about that you need with the static IP address. Now if you put an NLB in front of the ALB, you can get that static IP address, which is actually pretty cool. The other thing that you can get with ALB is that you can now enable private link. Now I just told you about some of the things about private link, and I'm going back on my whole this is a load balancer talk. But again, it's pretty cool that now you can take your workloads and create something that's more SASE if you have an ALB in front. Now we can go in the reverse. So how does this help out NLB? Well, NLB doesn't have the wide array of targets that ALB has, right? ALB can talk to containers, and I know NLB can talk to containers too, but not in the same fashion. It doesn't have the ingress controller. It does talk to Fargate, though, which is pretty cool, which I have a slide that talks about that in a second. But also you can have your serverless Lambdas, and you can also add on that integrated WAF and that authentication piece that ALB also enjoys. So between the two of them, you can kind of get best of both worlds. So here are some of the features that we have of recently launched NLB things. So TLS 1.3 is a pretty big one, especially for the gaming community. The ALPN support, which is cool, application level protocol negotiations, I think. So basically what that means is that the application will help you decide what gets encrypted over TLS as it's a TLS extension and what doesn't. Right? Again, this is helping you out to get faster and faster response times to your customers. I mentioned about the Kubernetes integration. You can go with the load balancer controller for EKS and Fargate. We understand UDP now for IP targets, which is cool. IPv6 is very, very cool. Now you don't have to worry about if you can meet the standards for things like government and healthcare, which are moving rapidly into IPv6. And of course, our session affinities and terminate our connections for our deregistered targets. So let's add this to our workload. So what I've done is now I've actually done two different things with my NLB. My API layer, I need faster speeds. So what I've done is I've replaced my ALB with an NLB. And then I'm taking advantage of private link. Let's say I have an ISV service out there somewhere, and I want to consume their service. And all I need to do is send them information. So I can basically use an endpoint, or if we want to flip the script a little bit, and I am not running the entire architecture here, but I am the ISV, I am providing that ISV with information, or with a path of consuming my services in a secure manner. The one thing, too, I want to mention before I forget is that the ENI for Private Link also has a security group that you put on it. So yet another layer of security. So one of the things I don't know if you've noticed is that some of those packets had a red ring around it. And that will lead us to the next load balancer. So I can have a target of an instance, and I can have a target of an IP address. I am trying to be a bump in the wire. I can auto-scale inspection-type devices. I use the Geneve protocol. I also use a form of private link myself. What kind of load balancer am I? What was that? Gateway load balancer, yes. Here we go. Now this is one of the cooler ones that I like because it does some unique things. I love the concept of bump in the wire because I don't have to worry about telling my application folks and my dev folks what I'm doing for inspection. They can carry on like nothing matters. And we'll explain how that works. So let's first talk about some of the workloads for Gateway Load Balancer. One type of workload is inspection. Gateway Load Balancer really thrives and does very well if you have a packet that goes through and gets encapsulated with Geneve. Everything gets preserved and gets sent into the back end, and it can be analyzed. So for metrics and inspection, you can count the number of packets, all sorts of cool stuff. The other thing we can do is security. Those inspectors could also be firewalls. You can decide to block, allow, whatever you want to do with those packets. So what makes it a little bit different? Let's go through Geneve. And I kind of lied to you a little bit saying I wasn't going to get into a bit of headers and packets, but it kind of fits here. So we set our routes to go to the Gateway Load Balancer endpoint. If we're going to send something to the internet, we make sure the Gateway Load Balancer endpoint knows where to go when it's done. We will have our source packet. We will then send that source packet, which gets encapsulated in the purple, down to our inspection devices, which will rip off that Geneve header and inspect the packet. And then the packet goes, if everything's okay, to the destination. So the whole flow and idea is the source and destination always look the same. They're not going to change anything. So it won't break applications, if you will, when you're doing this type of inspection. So again, I told you I lied that I wasn't going to show you any packet headers, but the reason why I wanted to kind of show you this, and it's the important piece to take away, is the ENI ID. The one thing that this enjoys, just like Private Link, is the Gateway Load Balancer in its VPC and its endpoint can be on the same IP address or same CIDR. So that basically means that you can leverage inspection with endpoints throughout your environment as long as your flow is correct and not have to worry about colliding with any existing IP addresses, which is actually pretty cool. I think anyway. So let's take a look at what it looks like. Now I'm going to do a simple ingress, right? Assuming that I'm using third-party devices to go ahead and do our inspection. So I have my side VPC that is under my control. I've loaded my gateway load balancer. I have a couple of auto-scaling groups. I need to make sure, though, that when I'm picking the firewalls that I want to do my inspection, and I strongly recommend going to the AWS Gateway Load Balancer page and make sure that they're supporting Geneve and Gateway Load Balancer. Because remember, a key piece to this is that they have to be able to remove those Geneve headers and then put them back. So I have my endpoints, my private link type endpoints, and because I like to do things well architected, I have 2 of them. And then I put in my route rules. My route rules say that anything that's going, I would do this probably with ingress routing on the IGW. Ingress routing is a different talk, but essentially what you can do is on the internet gateway, you can actually put a routing table that says anything that is destined to go to my right and left public subnets, please send that over to the Gateway Load Balancer endpoint for inspection. And then packets go ahead and fly. They go through, they do the route that we want, they actually get inspected. If everything is done well, it gets sent back to, in this instance, my ALB, and then reaches my end targets. Now again, notice one thing I have in here is that TLS inspection, or TLS, checking out whether TLS is there, that is the job of the actual firewalls that are behind the Gateway Load Balancer. The Gateway Load Balancer is a pass-through. And that's where its power is and its speed is it actually sends those packets through to the back end unmolested. That's why we're encapsulating them again with Geneve. So, as I like to do, let's add the Gateway Load Balancer into my workload. So we have more things to talk about. In this scenario, I'm doing something that we used to get asked about a lot about, of how do I do a services type VPC. I need a VPC that's central, maybe to my transit gateway, that will do inspection. The one thing I want to point out with this VPC that's very important, with everything being nestled inside, is I need to have routable boundaries for all of this to work. So my transit gateway endpoint is in one subnet. My gateway load balancer endpoints are in another subnet. And then my gateway load balancer points to the inspection devices behind that, because you have to route. Otherwise, because of the fact of the way VPCs are with local network, it will just basically bypass and go through the fastest route. So we actually have to force those routes with the subnet routing tables. Okay, now, which load balancer technology should be used for, I mean, this is kind of easy because there's only one left, right? So it's not, I don't really have to ask you, but our targets are actually the ELBs, the NLB, and the ALB, as well as IP address. Those are our endpoints. And we basically have something that accelerates that traffic. Now, how does it accelerate that traffic? Well, I'm going to explain it to you. Let's see. Why does the global accelerator matter? Let's talk about a great application that you've created, right? And you have it in one region. And everyone around the globe is basically using that one region. But because of the fact of the way the internet works and how the path to your workload may not be the same as the path back, you could have different latencies and different experiences for your customers. So one of the things that we recommend that you do is that you replicate your workload in as many regions where your customers are. So if you have dense amount of customers in the APAC regions, put your workload in the APAC regions. If you have dense workloads in the US or South America, definitely replicate throughout the areas. But then there's an issue. So if I'm going to have my workloads everywhere, and let's say I'm using an NLB or I'm using an ALB and I have them sitting out in the public, how do I tell my customers, hey, you're close to APAC, send all of your traffic to APAC. You're close to Ohio, send your traffic to Ohio. We could try to do something with Route 53, right? Because they have the geolocation and sending the address space. But if we have a problem, or if we have IP addresses that change, then your customers may have to refresh, or they might have to wait for the TTL to die on the FQDN or fully qualified domain name, right? So that would be a negative experience for your customers. So what Application Load Balancer does is it gives you a set of any cast IP addresses that never change throughout the globe. The reason why we give you a set is because, again, it's one of those Andy Jassy things, everything fails all the time. So we want to make sure that we give you a backup IP address and a primary IP address. And you would put that in Route 53, and if you were to have a problem, you only have 2 IP addresses to worry about, and you won't have to go back to your customers and tell them to refresh or to clear their cache whenever you want to do a change. But the other cool thing that you can do with it is if you have to do a change, any type of adds, moves, or changes, you have a lot of tools at your availability, and your customer will never know the wiser. So, for instance, you can do easy traffic control with your optimal endpoint selection. You would basically go ahead with a 5-tuple, and you would basically choose the optimal region, right? If you're in Ohio, send them to the Ohio data center. If you're in South America, send them to the South America data center, and the customer never knows the wiser, right? Now, hopefully, again, your workloads are replicated and kept in sync. Otherwise, they would know the difference, and somebody's going to get a call. But otherwise, this is pretty much optimal what we want it to do. And again, you get that pair of Anycast IP addresses that don't change. If you basically do anything to the load balancer, to the AGA, Global Accelerator, if you do anything to that Global Accelerator, the IP addresses are the same. The only way that they're going to change is if you destroy it and create a new one. The other option that you can do is you can do regional dials. Now, if a region is working, both regions are working, you're sending 100% traffic to both of them, you could actually go ahead and say do a rolling change. Or if you have a problem, heaven forbid, or you need to back something out, you can simply say, okay, you know what? I'm going to take this region offline in my Global Accelerator, and then all of my traffic will go to the only available region that's closest to your customers. Again, your customers never know the wiser. IP addresses don't change. Nothing gets set on fire. All that fun stuff. So then we also have what we call endpoint waits. Endpoint waits will actually allow you to do those changes or effects inside your regions. So in this example here, I've got maybe a change going on in my lower region there, and I want to send most of my traffic to one of my ELBs. My other ELB, I'm doing something or I'm rolling in a different change, and I can affect that slowly, right? And then I can ramp up the traffic, and you can use the Global Accelerator to do this. The other thing you can also do is your client affinity. So with 2-tuple on your client affinity, some of your applications may require you to continue to communicate to the same targets or back-end targets. Now, with this example, you can absolutely do that with the Global Accelerator. The other thing, too, I want to note as well is if you're not using IP as your target, but your endpoint is actually an ALB or an NLB, your health checking on the Global Accelerator is inheritive. So you set up your health checks on your ELBs. Those health checks actually get passed up without you having to do anything to your AGA. If you have an IP address, the health checking looks just like the other health checks you would see, say, in Route 53, where you can set up the different parameters. I would always recommend, if you're going to do anything like that, to create a status page, right? That will actually help you much better so that your application can actually say if it's doing well or not. I was one of those folks before I joined AWS who actually had just a protocol and said, if you can ping it, it's alive. And then, of course, there was a couple of birthdays that I missed because of that stupid mistake. So I don't want you guys to make that mistake. So let's add Global Accelerator to our workloads. Now, it'll be a little tough to add it to the previous thing that I had. So what I'm going to do is break it out a little bit differently. I have 2 different regions. I'm going to go ahead and set up that Global Accelerator. And remember, Global Accelerator runs globally, and it uses points of presence. So those points of presence sit closest to your customers and attaches to the AWS backbone, and you get delivered a pair of IP addresses. Now, I'm only representing one IP address here because I didn't want to clutter up the screen too much, but you get a pair. And then your customers within the local area, go ahead and start to speak. Okay, so one other thing that I always talk about too, in all of the talks that I do, is I talk about infrastructure as code. Now, we have application people, we have networking people, we have DevOps people. Now, DevOps people, please help everybody else with this. Because of the fact that you're in the cloud, there is no excuse to have to do anything manually to set up your infrastructure. We love flywheels in AWS, so I've set up a small flywheel about this. Whenever you go through an exercise, you always get your improvements and your metrics of what you do, right? We understand what worked and what didn't work. And then we want to automate it so we don't have to manually do it every single time. CloudFormation, Terraform, whatever you like, right? After that's done, you want to then say, hey, if I want to make a change, instead of doing something like go to the console, go to my command line and make all those changes, I can go and say do a get pull from CloudFormation or Terraform, make the changes I need to make, get some approvals, hopefully, and then go ahead and push those out. So now you can make changes to your infrastructure that much quicker. Then for your troubleshooting, you actually have a record of what you did. Instead of he did this or she did that or they did this, right? You can actually go back and check between the different iterations of your code and say, okay, I know what changes I had. If I need to, I can do rapid rollbacks. I can basically have my time to recovery be that much quicker and that much faster. And then, of course, the flywheel, all those improvements that you did, you put into your improvements and into your metrics. So that's pretty much a lot of what I had to say today. One other thing I wanted to do is a shameless plug, is that on every Thursday, I think it's 10:30 for Pacific time and 1:30 for Eastern time, myself and a couple of other network specialists host a Twitch show where we talk about all things network, right? Applications, load balancer, gateway load balancer, network load balancer, they're all included. And it's interactive because it's over Twitch. You can actually ask us questions. We will actually give you answers back right then and there live. And all of those videos, like this today, is recorded. So you can go ahead and go there. The other thing, too, is please complete a survey. It really helps me out to know how well I did, how I didn't meet your expectations and crushed all your dreams. Or that I did, so please give me your honest feedback. It's much appreciated. And now we have some time left for questions, if we have some. And the other thing, too, I wanted to mention for questions, people are wearing masks and kind of muffled, so if you wouldn't mind standing up and saying them. And I saw somebody back there. Go ahead.
In one of the slides, you had mentioned that the NLP can now have a UDP as a target.
What was that? NLP can have? UDP?
Or UDP protocol, can use UDP protocol.
That is correct.
For the targets, but can it do a health check somehow, or can we pre-configure it for some kind of a response? Because I want my NLP to actually test the service, not test the TCP port if I'm actually running a radius service.
Okay. So the question is, if I have UDP as my protocol with the NLB, how do I health check that? Yes. Okay, that's a common question, and it's a good one. And it actually applies as well to the Global Accelerator. The way that you do that, unfortunately, is you have to do an IP health check. And again, it comes down to creating that status page. I can't stress that enough, of having a status page of something that goes through, checks out your entire application, makes sure that the UDP portions are actually working and up and going, and then you can have, say, a match string or a match response, and that's how you can actually health check your UDP. Any other questions?
Cloud Accelerator rely on CloudFront Edge for the Global Accelerator.
Mm-hmm.
Is it relying on the CloudFront Edge?
Okay, so the question is, and correct me if I'm wrong, does Global Accelerator rely on CloudFront? It does not. CloudFront is a separate service. I usually get this question quite a bit too in a different way. He didn't ask it in this way, but what's better? Why would I use one over the other? There are two different kind of animals. You can use them together, but remember, CloudFront is really used for caching at the edge, right? Storing static information and then getting that to your customer. With Global Accelerator, it operates at layer 4, right? So this could be used for a wide array of things. Another thing that the Global Accelerator does, and I didn't cover it in this presentation because of the fact that this is a load balancing presentation, is it also accelerates VPN. Right, so there's other things that you can use other than just like, say, standard HTTP type communications to accelerate those workloads. So two different types of animals. One is for CloudFront to get the information in, caching locally. The other one, getting your customers connected to the AWS backbone and reducing your latency. Yes, sir?
You mentioned using Global Accelerator for cross-region and compared that with Route 53.
Mm-hmm.
So if you're using Route 53 to balance across region, if one region goes down and it just does it automatically route to the other one region, or
So the question is, if you're using Global Accelerator to balance between regions versus Route 53 to balance through regions, is it the case where if one region or connection to one region goes down, neither one will, or which one will or will not pass to the other side? Is that kind of close? So with Route 53, it will in fact, because of the fact that you're going to put in a secondary FQDN, go ahead and send your traffic over to whatever you're CNAMing, right? Because it will have a health check and it will determine that something is down. But the difference there is it's an all or nothing, right? You can configure, if you want to do like some traffic within one side and some traffic within the other side, right, with Route 53, but you're not going to get that closer connection to your customers, that accelerator part. So with the Global Accelerator, you can obviously, again, geolog, or if you have an outage, it can detect things that are down, but its level of detection goes all the way down to the ELB itself, right? Whereas when you're doing Route 53, again, you can create the status page, like I said, put it in your health check, and determine that something is operating or is reachable on one side or the other, but it's not as fine-tuned, right? If it sees one small problem, it's all gone. Whereas with the Global Accelerator, if it sees a problem inside somewhere within the VPC, you can still operate and operate effectively and well. It's not all gone. Yes, sir.
Might be a bit of a newbie question, but when you're putting your workloads behind the load balancer, they're sitting on private subnets.
Mm-hmm.
But when you add a new endpoint inside private subnet, why does that imply an extra endpoint in the public subnet?
Okay, so the question is, if you're adding something to a private subnet that you have a load balancer in front of, why does that imply adding another endpoint in the public subnet?
Correct.
And I'm thinking you're referring to the IP addresses that get expanded on an ALB that I showed in that one slide? Okay, so remember, ALB operates on an endpoint status. So as you're growing your fleet, right, it needs more IP addresses that will actually allow the communication to take place to get to the back end. The endpoint kind of is like a rotating dial, if you will. So if you query an endpoint multiple times in a high traffic scenario, you'll get different IP addresses, right? Those different IP addresses have their different limits and weights. So it needs to consume. Remember, again, the ALB is a compute-based ELB, or elastic load balancer. So it basically is spinning up more compute, and it has to assign it something.
So it's essentially the inside IP address of the load balancer itself on the public subnet.
So remember when I'm talking, so you were saying if the inside IP address of the inside, but remember I'm speaking of when you're growing it, it has to grow its presence publicly as well as on the back end. So that's why the endpoint actually gets more IP addresses for its fleet.
Public endpoints don't change, but on an ALB, essentially you have two.
Yeah, it doesn't change, it just adds more IP addresses to it.
On the inside, they need to talk to the back-end endpoints in the private subnets, so those are the IP addresses that the workloads see as the connections. They're coming from the load balancer, but they're private IP addresses.
Correct.
They're coming from the public subnet.
Correct. So the load balancer itself is actually,
That's how they're routed.
yeah, that's actually how it's basically accepting the connection, terminating, and sending it on. Yeah, exactly. And if you have more questions about it, please, I'll be right outside in the larger hallway. We can discuss it more to make sure it's a bit more clear. Any other questions? Yes, sir.
Continue on the same question. If you put a network load balancer in front of your application load balancer,
Mhm.
and if the traffic increases, the ALB will add more nodes, hence more public IP.
Mhm.
That the network load balancer will always have one single
That is correct.
for your customers.
Yeah, so if you have an NLB and an ALB, right, and the question is if we increase the traffic in the ALB, as we've discussed, as it gets used more, it will expand more IP addresses. That is correct. The NLB will not. It will still have a single IP address in the front. Any other questions? All right, perfect. I guess I'll let you guys out a little bit earlier. Thank you very much for coming, and look forward to seeing you guys throughout reInvent. I will go over into the hallway over here, not right here because they'll yell at me, but if you guys have any further questions, I'll be happy to take them for you.